Imagine an ordinary tree growing for decades or even centuries while surviving droughts, heavy rain, fires, and changing climates. Its history becomes stored inside the wood through growth rings, cracks, and the structure of the trunk. Once the tree dies, however, it normally begins to rot as fungi, bacteria, insects, and oxygen slowly break it down until almost nothing remains. For a tree to become stone, a very different chain of events has to begin. The first important step is rapid burial, because the wood must be covered before decay can destroy it. A volcanic eruption might bury a forest beneath ash, while a flood can cover fallen trunks with mud and sediment. Trees can also be carried into rivers or lakes, where layers of material gradually build up around them. Once the wood is buried and mostly cut off from oxygen, decomposition slows dramatically. That gives the tree something fallen wood usually does not have enough of: time. Burial alone is not enough, though, because the next part of the process depends on water moving through the ground. Groundwater constantly travels through tiny cracks and spaces in rock. As it moves, it can dissolve minerals from the surrounding material. One of the most important is silica, which is also involved in forming quartz. When this mineral-rich water reaches the buried tree, it begins moving through the wood itself. Wood contains countless microscopic spaces that once transported water and nutrients while the tree was alive. After death, those same pathways allow groundwater to penetrate deep into the trunk and carry dissolved minerals with it. As the water passes through the wood, some of those minerals begin to settle inside the empty spaces. This is where the real transformation begins. The tree does not simply become harder until it turns into rock. Instead, minerals slowly fill the spaces inside the wood and form around its original structure. This process is known as permineralization. A useful way to imagine it is as a wooden sponge being filled very slowly with mineral material. Water enters the wood and leaves behind tiny amounts of minerals before moving away. More water arrives later and adds another layer, so the process can repeat again and again over a very long period of time. As more minerals accumulate, more of the internal structure becomes filled with stone-like material. What makes this process remarkable is how much detail can survive. In some examples of petrified wood, scientists can still identify microscopic structures that once belonged to living tree cells. Over time, some of the original organic material can also break down and disappear. Minerals may gradually take its place while preserving the shape of the wood almost perfectly. This is why saying that a tree simply turns into stone is slightly misleading. The wood is not directly changing into rock. Minerals are filling its structures and sometimes replacing much of the original material while keeping its shape. That is why bark can remain visible and why growth rings can survive. It is also why a piece of petrified wood can still look almost exactly like a log, even though its physical properties are now much closer to stone. In many famous examples, silica eventually forms minerals such as quartz. Quartz is far harder than ordinary wood, so a trunk that was once soft enough to cut with a saw can eventually become a heavy piece of solid stone while still keeping the appearance of the original tree. The colors of petrified wood can make the result look even stranger. Some pieces are red, orange, yellow, black, green, or even purple. These colors usually do not reflect the appearance of the living tree because they are created by elements and minerals that entered the wood during fossilization. Iron can produce red, orange, and yellow tones, while manganese can create darker shades. Other impurities can change the color even further. This means the final appearance depends not only on the tree itself, but also on the chemistry of the groundwater and the rocks around it. Two trees from the same ancient forest can therefore end up looking completely different. There is also no single amount of time required for petrification. It does not always take exactly 1 million years or 10 million years because the speed depends on temperature, water chemistry, the amount of available silica, burial conditions, and the type of wood. While minerals are accumulating inside the buried tree, the world above it continues to change. Sediment can pile up as rivers shift their courses and volcanoes erupt before slowly eroding away. Climates change, forests disappear, and entire landscapes can be replaced while the ancient trunk remains hidden below the surface. Eventually, erosion can expose it again. Wind, rain, and flowing water slowly remove the rock and sediment that once protected the tree. After millions of years, the petrified trunk may return to the surface. The result can look almost impossible because it may still resemble an ordinary fallen log. Bark can remain visible and growth rings may still cross the surface, surface. Yet the material is now cold, heavy, and hard. What once behaved like wood now behaves like stone. Petrified wood is more than just a strange natural object because it can preserve information about environments that disappeared long ago. The structure of the wood may help scientists identify what kind of tree it was, while growth rings can sometimes reveal clues about the conditions in which it grew. The surrounding rock can also provide evidence of ancient rivers, lakes, floods, volcanic eruptions, and forests. In this sense, petrified wood acts almost like a geological photograph. It preserves the shape of a living organism through a process created by burial, groundwater, minerals, and time. The strangest part is how ordinary the story begins. A tree grows, dies, and falls to the ground. By chance, it is buried quickly enough to avoid complete decay. Mineral-rich water enters the wood and slowly fills its microscopic structure, while some of the original material disappears and minerals take its place. Millions of years can pass as the forest vanishes and the landscape changes beyond recognition. Yet the trunk can remain preserved underground until erosion brings it back to the surface. By that point, the tree is no longer truly wood. What remains is a stone copy of a living organism that once grew in a world that disappeared millions of years ago.